In this section, we're going to start taking a look at the VPN technologies. Now, when it comes to VPN technologies, we're going to break this down into a couple major breakdown pieces. We're first going to take a look at the concepts of VPNs and the VPN terminology, and then we're going to take a look at VPN architecture, route information propagation, routing distinguishers, or route distinguishers, the RDs, the route targets, or the RTs, and the virtual routing tables, or the VRFs. Now, in our VPN concept, we need to take a look at the traditional router networks. And traditional router-based networks connect customer sites through routers connected via dedicated point-to-point links. Now, that definitely does work, and it has been was for a very, very long time the de facto standard of getting stuff done. VPNs replace dedicated point-to-point links with emulated point-to-point links that share common infrastructure. So you no longer have to go out and have a trenched cable between your two locations. You still can do that. It's more or less available, but it's easier for providers to scale quickly by having VPNs in play. So customers use VPNs primarily to reduce their operational costs. So some of the advantages of VPNs that we'll take a look at are going to be cost savings. So you can replace expensive long distance lease lines with much less expensive dedicated connection to the service provider, whether that's DSL, fiber, cable, Ethernet, whatever it might be. And you're offloading support costs. So you could say, hey, AT&T or Time Warner, I want to buy service from you, but I don't want to manage it. So now you can say, I'm going to go ahead and have them do the cookie cutter managed CE type of rollout to where they take care of everything for you. You call up and say, hey, whatever, I've got some sort of problem. Don't have reachability here. And they can immediately jump in there and take a look at it because it's their device. Now, they might just have to call in and say, hey, can you verify power? Which is, having worked for a service provider for a while, that when you have your level 1 knock support people call in, they're going to be saying, hey, can you verify power? Because before they go out and dispatch a technician out to the site, they want to make sure that there's at least power there for them to be able to do something. Here's scalability. Adding a new VPN or adding a new branch office is fast and simple by adding an additional link to the ISP. We'll see exactly how this works out when we start rolling out additional configuration options. We're going to keep the two customer type of setup that we had in the previous course inside of Edge, where we had customer 1 and customer 2, and we did a lot of trace routes and things like that to show you MPLS TE and quality of service. So those aspects are still going to stay. We're just going to add a few more sites to them. Improve security. Use of encryption protocols and authentication. You can, if you are so inclined, you could run a DMVPN or a site-to-site VPN over the L3 VPN. So you might have some sort of requirement through some sort of compliance that is necessary as the customer that you need to encrypt your data going over the MPLS VPN. It technically speaking isn't necessary because it's going to be a private WAN circuit. However, for a compliance aspect, if you're doing some sort of like PCI or SOX or HIPAA compliance and they say you need encryption, it's easier just to toss it on there. And if you have some sort of issue, call the provider. We can open those ports. Better performance. So more high capacity data service options can be used, cheaper bandwidth. So nowadays, it's very possible I have lots of customers that have point to multi-point and point to point layer 2 and layer 3 services that are in the hundreds of megabits per second. Normally speaking, layer 3 VPN is typically going to be a lower bandwidth type of setup, and L2 VPN is going to be a higher level of bandwidth. So normally I see between 100 and 150 to 300 megabit per second L3 VPN services. It is very common in L2 VPN, whether it's AToM, VPLS, HVPLS, PBB, EVPN. I usually see those in excess of a gigabit. And it just depends on the type of setup the customer needs. Typically, you're going to use the layer 2 overlay, layer 2 data center interconnects to do things like vMotion and database replication and things like that. Flexibility and reliability. Now, widespread availability of fiber DSL and other broadband options are available and using more than one ISP. Now, we're going to take a look at as we move in here to having a couple of customer sites connecting to more than one service provider, because we're going to be taking a look at things from the perspective of a little bit of path diversity and how that would come into play and what that's going to take a look like. Now, we're not going to be doing anything like we did in an advanced route where we have your multi-home 2 and 3 times over, and you might have 5, 6, 7 BGP feeds. We're not going to be doing that because a lot of what we're going to be doing is going to be specific to private WAN, which is the bulk of what we're going to be taking a look at here, both layer 3 and layer 2. And then greater access to mobile users. So now you can have your employees work from home. Now with the advent of things like Cisco's AnyConnect VPN and things like for a long time I had a Cisco IP phone that I would have sitting at my desk here, and that it would VPN back into a ASA, and then I would be able to register a call manager. Things like that do come into play. More and more people are going to, I believe it's the DX80 is what I see for collaboration, where you literally dial into a number and people you're able to have a phone call over the internet and things like that. Skype and Google Hangouts and things along those lines. Those are becoming more and more popular. So when it comes to VPN terminology, we're going to need to break down some very, very basic aspects of this stuff. Now, in CCNA, I did a very basic breakdown to how you would get connectivity from your customer provider edge to provider edge through MPLS. And I just did a trace route to show you what the label switch path would look like. And in the last course, in Core, we took a look at configuring L3 VPN, and I walked you through about a 45-minute video of how to set up a very, very basic L3 VPN. It was very vanilla. It was just getting the connectivity up and running and allowing the customers to talk to each other over the MPLS core. We're going to basically take what we learned there, and we're going to talk about all the other capabilities that were available for L3 VPN, scale that to inter-AS VPN, both options A, B, and C, and carrier supporting carrier, and then we'll take a look at layer 2 VPN from the respects of I've got layer 2 circuits here and there, and I need to work with those to make sure everything works the way that I need it to. Now, what you're going to connect to at the end of the day from the customer perspective is the provider network. This is the service provider infrastructure used to provide VPN services. Now, they could be offering all kinds of different VPN services. It could be IPv4 point-to-point unicast. It could be IPv4 point-to-multipoint unicast, meaning you have 2, 3, 4, 5, 6, 7 sites connected to each other. You could be doing multicast VPN, which we'll take a look at a very basic multicast VPN setup with the data and default MDT multicast distribution trees over the MPLS core to see exactly how that comes into play and how that would work out. Maybe you are a customer that has a site in the UK where potentially only IPv6 is available, and you need to connect to a site here in the US that is, is running IPv6 as well, or is dual stacked. So we'll take a look at both 6PE and 6VPE as we're doing that and how that comes into play. Now the provider network does all of this stuff. There's a lot of stuff that we're not going to be covering in this course because it's outside of scope, and I've actually added a lot of stuff into it that is applicable to VPN to try to be a launching point for any of you that are interested in going into CCIE. You'll have at least a general idea of how most of the stuff works. We're not going to go into each and every little sub feature. We're going to hit the big stuff first, and then we're going to work into some minor features afterwards. Now the customer network is the part of the network that is still under the customer control. So at the end of the day, that's your job to control that. It is pretty common, and at least in the service providers that I work for and work with, we typically are going to, when you buy service from the provider, we're going to provide you with a router. That router is going to allow us to get the data that we need to and from our network correctly. I would say on average, when we moved away from the customer taking care of and managing their router to our engineers taking over and deploying managed CE in about a 4-month window, at the end of last year, we flipped over around 900 customers from the customer managed router, meaning that they would take care of it, and then we went out and deployed a bunch of ISR 4Ks to connect into our network with us. The reason why we did that is because of the fact that we set it up and we had the engineers in the background to understand that. I would say 70+% of our customers didn't really understand BGP, and we had more than one connection to BGP into us. Sometimes we had path diversity and stuff like that, and DMVPN rolling over for a backup connection. So depending on the situation at hand, if I have a 900 customers and I've got 20 of those a day that are having a problem, my whole day is firefighting. Well, that could be kind of that could be if I have other projects that I'm working on, because that's normally what we do is it's project-based work. If I have to do a support call where a customer's connection to the network is goofy because they don't know BGP that well, then that would be a problem for us. So we flipped over to a managed CE where we would take over and manage it. We configured everything. We had a pretty straightforward template that we would drop on a router, get it up and running, give it to the customer. They would spin it up, and then they would connect into our network. We would manage it remotely. So that gave us a lot of flexibility in that regard to get everything up and running that we needed to. So depending on the situation in hand, you could see a managed CE where the provider handles everything, or you could see a customer managed CE where you peer with us if you claim that you are good enough for it and you don't want to buy the service from us. Hey, you can manage it all day long if you'd like. But at the end of the day, it really depends on the situation at hand. That's why it fit into customer network in that respect. That's why I went in to discuss that. I've seen both. More commonly, you're going to see managed CE. But that doesn't necessarily mean that's going to be always the case. I have customers that they manage their edge. Their edge is completely hands off to us. We don't touch it. We have our provider edge. They connect to us. We set up the BGP peering. They connect to us. All is well. If they want to do some manipulation, we have a bunch of community values that we have set up to where if they send a community value to us, we do something to their traffic, something along those lines. Then you have the customer site, a contiguous part of the customer network and can encompass many physical locations. Typically speaking, when a customer sets up a network with us or peers to our provider's capabilities, what we end up doing is we end up basically taking whatever they're doing at their local site and giving them access to their other remote sites, and it looks pretty seamless. I mean, obviously they can tell they're going over an MPLS core and getting stuff done that way, but at the end of the day, that's what you can see. So at the end of the day, what we're trying to do is trying to make the customer's job easier. Simple as that. Now, when we talk about VPN terminology, it's good to see the provider versus the customer and the customer site and things like that. But we want to be more specific than that. We want to take a look at what the individual devices are in the MPLS core. So we're going to start off with the provider core. Now, this is the device in the provider network with no customer connectivity. This is only doing label switch routing, or I should say label forwarding, simply meaning that it's got IGP and it's got a label value or a label allocation service running. Now, why do I put it that way? Because if you remember from the core course, when we were going through MPLS and traffic engineering and things like that, you don't actually have to run LDP if you have MPLS traffic engineering enabled. Why is that? Because MPLS TE is not required to run LDP, and LDP is not required to run MPLS TE. So those devices in the middle, as long as the PE devices that are running and it isn't solely on the provider core devices for this, or the provider edge I should say, that any device in the MPLS domain can run MPLS TE, but the fact of the matter is, typically speaking, in a normal MPLS L3 VPN environment, the provider core is running IGP and LDP. That's the most common design. That's what we're going to run with for the most part until we get later on in the course. We'll take a look at doing TE and how that would come into play. Then you have the PE device. This is what's going to connect to the customer devices. So this is what you end up doing. You end up connecting to as a customer. You connect to a provider edge. This provider edge device is doing both label swap or label imposition, label disposition, and then you're doing VPN-B4. You could be potentially doing IPv4 BGP in the core as well, depending on the situation at hand. And then more than likely, you are doing BGP to the customer. You don't have to, and we'll take a look at all the different variations of PE to CE routing later on. And then you have the CE device, which is where the customer's device is on-prem. So, or the CPE, the customer premise equipment. This is what I will configure as the engineer and then ship to the customer. You power it on, put it in your rack, and you're going to have a connection into our network. Simple as that. And the PE to CE link is the link between the PE router and the CE router. This is where, if we refer to as the attachment circuit in layer 2 VPN, it's also applicable there as well, because that's going to be the circuit that you attach to the provider with. Now, when it comes to VPN models, there's a couple of different variations of it. We have the overlay model, which is where the service provider provides virtual point-to-point links between customer sites. And then we have the peer-to-peer model, in which the service provider provides in the customer routing. Now, depending on the situation at hand, we could take a look at a couple different aspects of this. With overlay routing, or overlay VPN, you're implementing optimum routing requires a full mesh of virtual circuits. Now, virtual circuits are provisioned manually, and bandwidth must be provisioned on a site-by-site basis. Overlay VPNs also incur encapsulation overhead like GRE and IPsec. Now, when we talk about this, this means that the provider does not see the data. A DMVPN, a multi-point GRE tunnel, IPsec VPN, those are overlay, which means that the provider is only getting you from your local site to your remote site. You're not doing MPLS VPN at this point. This is where you're doing something other than that. So overlay VPN simply means that you're routing over the provider. They're just simply getting you from point A to point B, regardless of how many hops there are in between. Now, with peer-to-peer VPN, it's a little bit different. The provider is participating in your forwarding, and you are more than likely using MPLS VPN, which means that there is an MPLS core that is set up somewhere, and you are paying for you're paying for the advanced capabilities. You know, you're paying for your QoS markings to be honored. You might be adding additional services and things like that that could be incurred. But at the end of the day, you are connecting to the provider, and the provider sees your traffic and is able to manipulate it if need be.